In this video, I want to explain the pushTail1 function. Below is the definition. On the right hand side, I have our main function. And inside of main, I have created a head pointer that is currently set to null. And I call the pushTail1 function 3 times. Notice how I am setting the pushTail1 function to our head pointer every single time I call it. And that is because pushTail1 function returns an address that will be set to head. To illustrate this, I am going to trace the function code. Let me first create an activation record for main. Inside of main, we have a head pointer. And let's just say that this head pointer has an address of 0x40. And it's currently pointing to null. Then we go to this line and we call our pushTail1 function for the very first time. And so an activation record is created for pushTail1. And so we go to the code, and the first thing that we do is we create our nodes by using the malloc function here on line 184. We have a head pointer, and when we call this, we currently pass the address of the headed main. We get to line 184, and a new node is created. On line 190, our data is entered into the data portion of our node, and in this case, our data is 45. On line 191, we set the next portion of our node to null. Then we go to line 193 and a current pointer is created. And this current pointer holds the address of head, which is currently pointing to null. We then go to line 195 and our compiler will check if the list is empty. On line 196, if head equals null, well, it does equal null. And if that's the case, our new node is assigned, or our new node's address is assigned to head. Head will now hold the address of 0x100, and current will also hold the address of 0x100. The compiler then skips this while statement after the if statement is executed. We then go to line 208 where it says return head. And what we're basically doing here is we're returning the address of head. And the address of head is 0x100. Here, this is the same thing as head equals 0x100. And so now this will become 0x100. And it will be pointing to our node that we created in the heap. After line 208, we then complete the execution of this function. The pushTail function will then be popped off the stack frame. And after it's popped off the stack frame, this is what our pictorial representation looks like. We have a head pointer in main that is pointed to the address of 0x100, which is our first node. We then go to our next function call. A new activation record is then created for pushTail1. The address of head, which is 0x40, is then passed on to the head pointer that is created in the parameter of our pushTail1 function, and that is currently pointing to 0x100. We then go to line 184 and a new node is created, and this new node holds the address of the newly created node in the heap, which is 0x200. We then go to line 190 where data is assigned to the data portion, and in this case 50 is assigned. In line 191, the next portion is assigned the null value. The compiler then goes down to line 193 and a current node is created. And that current node takes on the address, or the address of head is assigned to that current node. So current will be pointing to our first node. The compiler will then check if the list is empty. Does head equal null? Well, no, head is holding the address of 0x100. And so this if statement will be skipped. It goes to the else statement and it checks this condition while current next does not equal null. Well, current, here's our current, and the next, well, it does equal null. And since it equals null, it exits this while condition. And then our current next, or arrow next, the new node's address will be set to that. So this will now hold the address of 0x200. And then we go to line 208 and the address of head is returned. Well, what is the address of head? It's 0x100. It still holds the address of the first node. So this will be the same thing as head equals 0x100. This address will be assigned to this head pointer. After that's done, the execution of this function call will then be completed, and our activation record for pushTail1 is popped off the stack frame. And this is what we're currently left with. We then go to this line and we call this function for the third and final time. An activation record is again created for pushTail1. A head node or a head pointer is created, and that's going to be pointing to the first node because it's taken on the address of our head in the main function. We go to line 184 and a new node is created. And this new node holds the address of 0x300. 185 to 189 is just a error check to make sure that our heap has enough memory. And in this case it does. So we go to line 190 and data is entered. And in this case the data is 55. On line 191, the next portion of the node is set to null. We then go to 193 and a current node is created. Head is set to that current, so current points to head. We go to 195 and the compiler checks to see if the list is empty, and it does that by checking to see if head is null. Well, head is not null. We then skip this if statement and we go to the else statement, and then we check the currents next to see if this is null. Well, here's the currents next. It's not null. And if that's the case, we traverse current to the next node. So current is now pointing at the next node, which is 0x200. So current is holding that address. We then repeat our while condition. Does current's next equal null? Well, here's the next. And in this case, it does equal null. So this condition becomes false. And we exit out of this while condition. We then go to line 206 and we set the new node's address to current's next. And our new node's address is 0x300. So this becomes 0x300, and this is now pointing to the next node. We then return the address of head, and the address of head is still 0x100. So this is basically saying head is 0x100. We then complete the execution of this function, and our pushTail1 function is popped off our stack frame. And once that is popped off, this is what we have left. This head is pointing to the first node with its next portion holding the address of the next node, and this next holds the address of the next node. And once we get to this line, the output will be 45, 50, and 55. And let me compile that for you. 45, 50, and 55. As far as time complexity, because we have this while loop, the worst case scenario will be O of n, because we have to traverse before we can add the tail node. Best case scenario is constant if we don't have anything in our list, which is condition 196, then it's going to be O of 1. And this is the explanation for our pushTail1 function. Thank you.